Yeah, good evening to all. Uh, Actually, we had started such sessions in the previously around 20 days back. Professor M. N. Basaraju, who is the principal of the SJR College, and myself have taken the initiation for such events. Uh, M. N. Basaraj, sir.
Yes, sir.
Sir, speak about this few words, please. Few students have joined. Actually, we started this again from the basic for the especially for the beginners in the projects and the teachers who are starting with the projects in the electronics projects as well as using Arduino microcontroller especially. Professor, please.
Okay. Good evening, Dr. Malatesh and other professors and participants. Dr. Malatesh and myself from SGR College, we have commenced this webinar on basic electronics, Arduino microcontroller, circuit simulation, and electronic projects. Already good number of lectures or webinars have already commenced, and most every time quite new people will be joining the webinar. So for their purpose, Dr. Malatesh will give a brief introduction from the beginning, and then you will go to the recent topic. So after completing this webinar series, we will have a workshop in HCR College, Majestic Andhra Circle. There we will distribute the participation certificates. That day we will have an exhibition, electronic exhibition also. So the things will go in a very smooth and beautiful way. You will learn a lot, and even other resource persons are also coming. They are going to deliver good talk. And if you are interested, we are even going to provide the Arduino boards, even Raspberry Pi boards also, so that you can collect the boards from SGR College and you can do the projects. And after completing the projects, you can return the projects also. So that type of facility.
Sir, not audible. M. N. Basaraj, sir, not audible, please. Unmute yourself, please.
Yeah. So we will provide after the completion of theory, we will provide and we will make the arrangement to provide even Raspberry Pi boards also. You can collect the boards from SGR College, do the projects, learn the projects, and demonstrate to your college students, and then you can return the projects also. So this type of arrangement is made by RVC Engineering College. So if you are interested, you can register your names with Dr. Malatesh, and I will make the arrangement for providing the Arduino boards and Raspberry Pi kits. So with this introduction, Dr. Malatesh will continue his webinar. Thank you, Dr. Malatesh.
Thank you, sir. Uh, I welcome Professor Krishna Pratyapur from Degree College. So welcome you, sir. He is he is one of the senior professor in physics. Happy to see you, sir. Thanks for joining us. Thank you, sir.
Thank you, Krishna, sir.
Thank you, sir. Thank you, sir.
Well, in the last week, we had discussed a few concepts on the basic electronics, analog circuits and digital circuits, and how to simulate some of the circuits in the Tinkercad. But this week, the few people have joined. I'll show you how one circuit will be built in the Tinkercad and how to simulate it later. And I'll explain one or two circuits how to simulate in the Tinkercad. And later you can practice it, not a problem. But today's agenda is the Arduino microcontroller. I'll go to the point. So we have discussed all these things, Ohm's law, the diode characteristics, how to do in the Tinkercad. Without this is Tinkercad is nothing but a simulation tool. We can design the 3D models as well as electronic circuits also. And over the period, if you learn about it, we can do some other concepts also. But here we're going to concentrate on only the electronic circuits. So we can perform some of the experiments, the electronic experiments, also which are related to some of the physics related experiments also can be done, where we can utilize some of the electronic circuits. So once you practice these, you'll have some ideas and all. And once you have some ideas, you can build any circuit for any experiments in any other subjects also. This is the diode characteristics, what we discussed in the last class. And this is how to connect an LED for a power supply and register and a potentiometer. And this is the DC motor, how to run using the battery or the power supply. We have discussed this. And these are not the difficult thing. So the newcomers, you can practice it later. Just I'll show you one or the two circuits in the later part. This is C amplifier. How to simulate the C amplifier in the Tinkercad. We have practiced it. And in digital circuits like logic gates and all, we can perform. We have discussed the NOT gate and OR gate as the digital circuits. This is the OR gate. Now today's agenda is the Arduino, the microcontroller. Discussing the simulation of the Arduino, I will show you how to build one circuit in the analog circuit using Tinkercad, and I'll show you the simulation of the NOT gate or the OR gate later at the same time. Fine. Now the microcontroller, as the name indicates, it is the CPU of the computer. The processor, I think most of us heard about the processor and controller. There is no much difference between the processor and controller. Both are processor only, but the microcontroller is called a dedicated processor, means designed to the particular some specific applications. Now look at this diagram. This is the block diagram of the computer. So all of us have seen the computer and its accessories. So what and all will be put across the computer. We call usually the CPU, central processing unit, will be there, and many input devices will be there, many output devices will be there, and many memories also will be there. So we can call a mobile also a computer. because it has input devices, it has the output devices, and the control unit will be there as the, and in the CPU, these are the basic parts, which is the control unit, which controls all the IO devices, and this is the arithmetic and logical unit, which performs the arithmetic operation and logical operations. So each and every operation done by a computer will be either the arithmetic operation or logical operations. We know the arithmetic operations, addition, subtraction, and all, and the logical operations related to the logic gates like not, or, and, or, nor, and all those operations, which are the logical operations. And the memory units, the RAM and ROM will be there. These are the basic parts. So we call usually the microprocessor is nothing but the CPU. So if you ask the question, what is a microprocessor? So the simple answer is what? It is a CPU of a microcomputer. As you know, the different microcomputers are there. The different computers are there. Microcomputer, mini computer, mainframes, and so on. So we have a laptop or a desktop. So it is a microcomputer. So the basic difference is the number of processing units. So it involves. So which indicates it is like how many, whether a single person is doing a work or multiple people are doing a simple same work or something like this. So as the number of processor increases, definitely the speed will increase, and the capacity of the system will increase. This is what is a microcontroller. So it has the same what I said just now. Some of the concepts will be there. It has the some of the ICs, the microprocessor, RAM, ROM, AD. AD in the sense the analog to digital converters. So I'm talking now. So it is a analog information. So that analog information will have to be converted into digital, because it has to be performed in digital manner, and later it should be converted from digital to back to the analog. So we have the ADC, the analog to digital converter, and digital to analog converters. It is a small computer. Basically, before this, I'll come back to this slide. Otherwise, some of the differences between the microprocessor and microcontroller, as I said just now, it has the microprocessor. Actually, the timers and all will not be there in the micro processor, and most of the microprocessor will not have this memory also. Only the input and the output serial interface will not be there in the microprocessor, but in microcontroller it will be there. So you can observe the EEPROM, timer, the CPU, RAM, ROM, and IO ports. The IO ports, in the sense, these are the combination of the flip-flop like concept to which we connect the input device and the output devices. So a port, in the sense, it holds the data. Say, for example, if the processor has to send a data of an 8-bit or whatever it is to an output device, it will just store in the port, and from the port, the device will receive it. In the same way, when the microprocessor has to receive the data from an input device, it won't be connected directly to the input device, but those will be connected through these ports. We call them as the input ports and output ports. These ports will be, that depends on whether it is a 4-bit or 8-bit and so on. And the process also can be classified into well, the processor also can be classified into either 4-bit processor, 8-bit processor, and 16-bit processor, and so on. That depends the how many bits it can process at a particular moment. For example, a 4-bit processor, in the sense, at a moment it can add two numbers with the 4 bits. Means in one number there is, say, for example, number A 4 bits and number B 4 bits. So I'll give an analogy to you. If I ask a question to you, what is the 2 plus 4? So easily you'll say the answer. If I say 10 plus 20, you can say easily 225 plus 8, 56, something like this. If I go on adding the digits in the numbers, so you'll find a difficulty as the number of digits increase in the number. So in the same way, these the processors or the controllers will perform the arithmetic operation or logical operations with a particular number of bits in each number. Say, for example, 4-bit, I was explaining, 4-bit processor will take the 4 bits of one number, the 4 bits of other number, and next time again the 4 bits of the first number, the 4 bits of second number, and so on. So go on like this. Say, for example, uh, 125 plus 256. We start from the rightmost digit. So we take one digit at a moment, we add it and take the carry to we go move towards the left side. In the same way, these processors also will add the bits, but 4 bits at a moment of one number, 4 bits of other number, and move towards the left. In case of the 8-bit the processor, so of course the capacity is double, perform the faster. The same way 16-bit, 32-bit, and 64 bits the processors are there nowadays. Yeah, these are the
Malatesh sir, I think you're on mute.
No sound, Malatesh.
yes sir. Thank you.
Okay, now it's done.
Yeah, there are different microcontrollers are there. 8051 microcontroller and the PIC microcontrollers, many more are there, and the AVR microcontrollers are there. Now, in this session, so I'm going to discuss the Arduino, the microcontroller. This microcontroller is available in the different development boards like Arduino Uno and so on. These are the different boards with the Arduino. A few popular boards are the Arduino Uno, Leonardo, Lilypad, Mega, Nano, Mini, Mini Pro, BT, and so on. So over the practice, you'll come to know what are the features and all those things. Now, in this session, or in this the entire session, I'm going to discuss with the Arduino Uno. This is Arduino. Sorry, actually, the network issues. I think I am audible, right? Hello, sir. Hello.
Yes, Malatesh, you're
Yes.
audible.
Yes, sir. Yes, sir. Yes, sir. It's audible.
Yeah. Actually, here the some network issues are there. It is going to become off and on, so it is giving a small problem to me here. That's fine. Yeah, this microcontroller, this Arduino board will have this AVR Atmega 328, which is one of the 8-bit the microcontroller. This is the IC, which is that microcontroller, and it has the 14 digital pins are there. The 14 digital pins are there. This Arduino is not a microcontroller; it is a development board, what we call it. That AVR is a microcontroller, so that's going to be used in this the board. We call this is a development board. And this is with this microcontroller, whether the person working in the electronics industry or not, so he can utilize if he learns some of the features. Like this it is designed, and once you practice this with Arduino, you can practice other versions of the Arduino microcontrollers, and of course the microcontroller like 8051 and the other controllers, so you can practice it, not a problem. uh, as I say, as I was explaining, it has a digital pins. The 14 digital pins are there. Those are the these are the digital pins. Okay, uh, these are the analog pins. Okay, these 14 pins are named from the 0 to 13. You can observe here. This is 0 and this is 13. Total 14 digital I/O pins means we can use them as the input port or the output port. In the sense, the input pin or the output pin. Yeah, sorry. Again, it will be off and on, unfortunately. It has, we can connect for these pins or the ports. These are also called as the ports. Port need not be the combination of the usually 8-bit port, 4-bit port, we call them as, means all the 4 pins will have to be used. All the 8 pins will have to be used. But here, we can use a particular pin for an input device or the output device. And these are the analog pins from A0 to A5. Means we can connect the output from an analog, the sensor. Okay, for example, the temperature sensor or the light sensor, it converts the physical quantity into the voltage, that is the electrical quantity, the voltage or the current. So that has to be, that will be in analog basically. That has to be converted into the digital. So inside these pins will be connected to analog to digital converters. And these are the power supply uh, pins. It has 3.3 volts, 5 volts, and ground are there. Uh, and this is the DC power jack. This is a DC power jack. We have to connect DC voltage or the power supply for this. Usually we can connect either 9 volts or 12 volts. That's fine. And this is the USB jack, means from the laptop or the PC, we can transfer the code or the program to the microcontroller. Okay, and it has you can observe now here the LEDs, the TX and RX LEDs we call them as the transmitter and receiver. Means whenever the microcontroller will communicate with the external devices, when during the transmission and reception, these LEDs will the blink. That gives an indication of the bits are being transferred between the processor and sir, how much time is there, sir, so that I can restart? Is showing this? Hello, sir.
Sir, I think you have approximately 4 minutes 15 seconds.
4 minutes. Okay, I'll do one thing, sir. I'll stop now and restart. All of you, please log in with the same ID and password, please. I'll repeat. Please log in once again with the same ID and password, please.